There is a part inside every gasoline engine that most people never think about. It is not the piston. It is not the crankshaft. It is a small, heavy device, usually bolted to the back of the engine block, roughly the size of a man's fist. Inside it, a spinning, permanent magnet, a coil of copper wire wound 200 times around an iron core. A second coil wound 20,000 times around the same core, a set of breaker points, and a condenser. Together, these components do one thing. They turn mechanical rotation into a pulse of electricity, 20,000 volts, delivered at the exact instant the piston reaches the top of its compression stroke, that jumps across the gap of a spark plug and ignites the fuel-air mixture inside the cylinder. Without that pulse, nothing happens. The fuel sits. The piston does not move. The propeller does not turn. The truck does not start. The airplane does not fly. This device is called a magneto. The name comes from the permanent magnet at its heart. The principle is Faraday's law of electromagnetic induction, discovered in 1831. A magnet spins near a coil of wire. The changing magnetic field induces a current. The current flows through a primary coil of about 200 turns. A set of breaker points, a mechanically timed switch, snaps open at the precise instant of maximum current flow, collapsing the magnetic field instantaneously. That collapse induces a voltage spike in the secondary coil, which has 20,000 turns. The ratio, 100:1, multiplies the voltage from a few hundred volts to 20,000 or more. That pulse travels through a distributor to the correct spark plug at the correct instant, thousands of times per minute, while bolted to a vibrating engine in temperatures ranging from 50 below zero to over 200 degrees Fahrenheit, at altitudes where thin air makes electrical arcing unpredictable. In April 1917, when the United States declared war on Imperial Germany, there was exactly one company in the world that knew how to manufacture a reliable high-voltage magneto at this level of precision at industrial scale. That company was German. Robert Bosch was born on September 23, 1861 in Albeck, a village in the Swabian Highlands near Ulm. He was the 11th of 12 children. His father, Servatius, ran a large farm and a brewery, and was, unusually for his social class, a well-educated Democrat and Freemason who placed enormous importance on the education of his children. Robert trained as a precision mechanic. After completing his apprenticeship, he did what ambitious young German craftsmen of his era did. He traveled. He worked for Schuckert & Co. in Nuremberg. He studied at the Stuttgart Technical University, and in May 1884, at the age of 22, he sailed for New York, where he spent a year working under Thomas Edison and Sigmund Bergman. He also worked for Siemens in England. By the time he returned to Stuttgart, he had seen the inside of the finest electrical workshops in the world. On November 15, 1886, Robert Bosch opened his own workshop, the Workshop for Precision Mechanics and Electrical Engineering, in Stuttgart. He was 25 years old. He had one employee. But he had something more valuable than capital. He had spent a year working alongside Edison, and he had learned the American approach to electrical manufacturing, the emphasis on practical application, on products that worked, on getting things to market. He combined this with the German tradition of precision craftsmanship. The result was a company that valued both innovation and quality, both speed and exactitude. In 1887, a mechanical engineer walked into Bosch's shop and asked him to reproduce a magneto ignition device he had seen on a stationary engine made by Deutz, the Cologne-based engine manufacturer. Bosch traveled to Schorndorf, 20 miles east of Stuttgart, studied the device, confirmed it was not patented, and then built a copy. But he did not stop at copying. He replaced the bar magnets with U-shaped ones, making the device lighter and more reliable. Then he delivered it. Over the next few years, Bosch sold magnetos in small quantities, 9 units in 1888, just over 100 by 1891. They were designed for stationary engines, factory motors, pumps, generators. The magneto ignition device accounted for roughly half the workshop's revenue, but it was still a niche product for a niche market. The problem with early cars was ignition. Gottlieb Daimler's glow tube ignition required a dangerous open flame. Battery-powered systems worked until the battery died, which, in an era with no alternators, no charging systems, no roadside assistance, meant the car simply stopped. Every pioneer of the automobile understood this. Carl Benz himself called ignition the trickiest problem of engine design. In 1897, a customer asked Bosch to fit a magneto to a De Dion Bouton three-wheeler. Bosch assigned the problem to his factory manager, Arnold Zeringer, who had worked for him since 1890. Zeringer's solution was elegant. Instead of moving the heavy armature through the magnetic field, he left the armature stationary and rotated a lightweight metal sleeve around it. This seemingly small change made the magneto compact enough, fast enough, and reliable enough for the high-speed engines in motor vehicles. Bosch filed his first patent on June 11, 1897. 5 years later, in 1902, Bosch's chief engineer Gottlob Honold, who had started as an apprentice and would become one of the most important electrical engineers in automotive history, developed the high-voltage magneto ignition system. The key innovation was pairing the magneto with a specially designed spark plug, using a highly insulating ceramic for the plug body and a heat-resistant alloy for the electrodes. For the first time, an engine's ignition system was completely self-contained. No battery, no external power, just a spinning magnet and a spark plug. The effect was immediate and total. Having manufactured fewer than 50,000 low-voltage magnetos in the 5 years between 1897 and 1902, Bosch production accelerated exponentially. By 1912, the company had produced its 1 millionth magneto. In the United Kingdom, more than 90% of all automobiles ran on Bosch ignition. When the Mercedes 35 HP won the Nice-Salon-Nice race in southern France, it was equipped with a Bosch magneto. When the first Zeppelin flew, its Daimler engines used Bosch ignition. The company expanded with breathtaking speed. Sales offices opened in London in 1898, Paris in 1909, and across Europe in the years that followed. By 1913, Bosch had subsidiaries on every inhabited continent, and 88% of its revenue came from outside Germany. This was not a German company that happened to sell abroad. It was the world's first truly global automotive supplier, with manufacturing in multiple countries and customers in every market where internal combustion engines existed. Robert Bosch was also, by the standards of his era, an extraordinary employer. In 1906, he established the 8-hour workday at his factory, one of the first industrialists in Germany to do so. He paid wages 60% above the average. He invested in worker training, good ventilation, and bright factory floors. Years later, he would summarize his philosophy in a single sentence that became famous. "I don't pay good wages because I have a lot of money. I have a lot of money because I pay good wages." By 1910, Bosch was represented on every continent, and the largest market outside Europe was the United States. American demand for Bosch magnetos was enormous. In 1906, a single newspaper advertisement for the magneto ignition system generated $1 million in orders and doubled sales within a year. Bosch established a sales office in New York. Robert Bosch New York, Inc., founded September 6, 1906. Branch offices followed in Chicago in 1908, San Francisco in 1909, Detroit in 1910, Toronto in 1911. By 1908, the New York facility was assembling 8,000 to 10,000 magnetos per month, running day and night shifts. But assembly was not manufacturing. The components were still shipped from Stuttgart. In 1910, the United States imposed customs tariffs on imported components. Bosch's response was decisive: build a factory. In 1912, the Bosch Magneto Company opened a manufacturing plant in Springfield, Massachusetts, the first Bosch factory outside Germany. The site resembled a college campus. Each employee received a signed, embossed identification badge specifying which buildings and departments they were authorized to enter. In 1914, Bosch expanded further, purchasing a factory in Plainfield, New Jersey, and acquiring the Rushmore Dynamo Works, which moved the company into starters and generators. By 1914, the Springfield plant was producing complete magnetos from American-sourced raw materials built by American workers on American soil. These workers, machinists, assemblers, winding operators, inspectors, test engineers, were overwhelmingly American. Some were German Americans, some were Irish, Italian, Polish. They were skilled tradespeople who had been trained, many of them on the job, to manufacture what was arguably the most precision-demanding electrical component in the automotive industry. They understood the tolerances. They knew how to wind the coils. They knew the gap specifications for the breaker points, the magnetization procedures for the permanent magnets, the alignment of the distributor, the testing protocols. They worked for a German company, but they were American workers building an American product in an American city. Then, on April 6, 1917, the United States declared war on Germany. What happened next was not unique to Bosch. It was part of a nationwide convulsion of anti-German hysteria that swept the United States in 1917 and 1918 with a ferocity that is difficult to comprehend a century later. Sauerkraut was renamed Liberty Cabbage. Hamburgers became Liberty Steaks. Dachshunds became Liberty Pups. German measles became Liberty Measles. German language classes were eliminated from schools. German books were burned. In Cincinnati, German Street and Berlin Street were renamed English Street and Woodward Street. Germantown, Nebraska became Garland. Berlin, Iowa became Lincoln. South Dakota prohibited the use of German over the telephone and in public assemblies of 3 or more persons. A professor in Wisconsin was tarred and feathered for having a German name and teaching the language. In Collinsville, Illinois, a German-born coal miner named Robert Prager, who had applied for American citizenship and was suspected, without evidence, of stealing dynamite, was dragged from jail by a mob, stripped, and hanged. A jury found the members of the mob not guilty. President Woodrow Wilson himself set the tone. "Any man who carries a hyphen about with him," he declared, "carries a dagger that he is ready to plunge into the vitals of this republic." Against this background, in October 1917, Wilson appointed A. Mitchell Palmer as alien property custodian, under the authority of the Trading with the Enemy Act, passed just days earlier on October 6th. Palmer's mandate was sweeping: seize, administer, and, if necessary, sell any property in the United States owned by citizens of enemy nations. Palmer was a former congressman, a political ally of Wilson's, and a man with a keen understanding of patronage. He built a staff of hundreds and an investigative bureau to track down hidden assets. Palmer took to his work with enthusiasm. He would later describe his office as running the biggest general store in the country. Late in 1918, he reported managing nearly 30,000 trusts with assets worth $500 million, with another 9,000 trusts worth $300 million still awaiting evaluation. The assets of the Bosch Magneto Company were among the first seized. So were the Eismann Magneto Company, another German magneto manufacturer with American operations, the Hamburg American Shipping Line, the German-American Lumber Company, 20 German insurance companies, the New York Evening Mail, and, most famously, the American assets of Bayer, the chemical company, which lost its United States patent for aspirin. Bayer's factory was auctioned on its own front steps. Palmer also targeted German brewers, testifying before the Senate that the United States Brewers Association harbored pro-German sympathies and had attempted to buy a great newspaper and control the government of state and nation. Altogether, the United States government confiscated close to $500 million in foreign-owned property during the First World War. Palmer campaigned to keep the power to sell these assets rather than merely hold them, arguing that American industry must be made permanently independent of German investment. Even after Germany's surrender, he continued liquidating seized properties. His rationale, delivered to an audience of lawyers, was stark. The war power is of necessity an inherent power in every sovereign nation. It is the power of self-preservation, and that power has no limits other than the extent of the emergency. For the Bosch Magneto Company in Springfield, the seizure meant that ownership of the plant, its equipment, its inventory, its patents, and its trademarks passed to the United States government. Robert Bosch, sitting in Stuttgart, lost his American operation overnight. He could do nothing. A post-war German-American treaty would later specify that German citizens could institute no legal proceedings over wartime seizures. But here is the detail that matters most. The workers stayed. The machinists who wound the coils stayed. The inspectors who tested the breaker points stayed. The engineers who calibrated the test benches stayed. The men and women who ran the production lines, they were American citizens. They had not been seized, they had not been deported, and they knew how to build magnetos. The government needed them, because in 1917, the United States faced a crisis that almost no one outside the engineering profession understood. When the United States entered the war, the Army possessed fewer than 300 aircraft, most of them obsolete trainers. The French government immediately urged Washington to produce 6,000 fighters, 3,000 observation planes, and 2,000 bombers for the 1918 spring offensive. Congress responded with an appropriation of $640 million, 45 times the entire 1916 federal aviation budget. It was one of the largest single military expenditures in American history to that date. The centerpiece of this program was the Liberty engine, a V-12 designed in 5 days at the Willard Hotel in Washington by Jesse G. Vincent of Packard and Elbert J. Hall of Hall Scott. The War Department ordered 22,500 units. Production contracts went to Ford, Lincoln, Packard, Buick, Cadillac, and Marmon. Henry Leyland left Cadillac to form the Lincoln Motor Company specifically to build Liberty engines after William Durant, a pacifist, refused to use General Motors facilities for war production. The Liberty was an impressive engine, 400 horsepower, 12 cylinders, designed for mass production using interchangeable parts. It would become the most important American contribution to aviation technology during the First World War. Over 20,000 were built by the armistice. But the Liberty had a problem, a critical one. Every aircraft engine needs magneto ignition, not battery ignition, magneto ignition. A battery can fail, a battery can run down. At 12,000 feet over the Western Front, with machine gun bullets punching through your fuselage, the last thing a pilot needs is an ignition system that depends on an intact wire running to a battery. A magneto is self-contained. It generates its own electricity from the mechanical rotation of the engine. As long as the engine turns, the magneto fires. That is why every military aircraft engine in every country on both sides of the war used magneto ignition. That is why every military aircraft engine to this day uses magneto ignition. And in 1917, the United States could not build 12-cylinder magnetos. No American manufacturer had ever produced one. The domestic magneto industry consisted of a handful of small companies, Splitdorf, Dixie, KW, Burling, that made adequate 4- and 6-cylinder magnetos for automobiles and tractors. None of them had ever built anything for a 12-cylinder aircraft engine running at the speeds, altitudes, and vibration loads of combat aviation. The precision required was beyond their experience. The tolerances on the breaker points, the insulation of the high-voltage coils, the magnetization of the permanent magnets, the timing of the distributor, all of it was Bosch territory. This is why the Liberty engine used a Delco battery and coil ignition system instead of magnetos, a compromise that the engine's own designers knew was second-rate. Jesse Vincent and his team specified off-the-shelf components whenever possible, and the Delco system was the only American-made ignition available for a 12-cylinder engine. As one engineering historian noted, 12-cylinder magnetos simply did not exist on the American side of the Atlantic. Battery ignition was adequate for automobiles on flat roads. It was not what you wanted in a biplane being shot at over the Meuse-Argonne. One bullet through the battery lead, one severed wire, one connection jarred loose by anti-aircraft fire, and the engine died. There was no backup. There was no redundancy. Every European aircraft engine, the Rolls-Royce Eagle, the Hispano-Suiza, the Mercedes D3, the BMW 3A, used dual magnetos, two completely independent ignition systems, each with its own set of spark plugs, so that if one magneto was destroyed, the engine would continue running on the other. The Liberty, America's great contribution to aerial warfare, went into combat with the same basic ignition concept as a Model T Ford. The situation was made worse by the conflict of interest surrounding Delco's involvement. Edward Deeds, chairman of the Aircraft Production Board, had financial connections to Delco through his association with Charles Kettering's companies. Over 20,000 Delco ignition systems were purchased for Liberty engines, and Deeds was eventually removed from the board amid accusations of war profiteering. But the deeper problem was not corruption, it was capability. America simply lacked the manufacturing expertise to build aircraft-grade magnetos. This was the magneto gap, and closing it became an urgent national priority. The seized Bosch plant in Springfield was the obvious answer. It had the tooling, it had the workforce, it had the institutional knowledge. What it no longer had was German ownership or German engineers. Under government operation, the Springfield plant continued manufacturing magnetos throughout 1917 and 1918. The American workers, who had been building Bosch magnetos for years, simply kept building them. They knew the designs. They knew the manufacturing processes. They had the drawings, the jigs, the fixtures, the test equipment. What they had learned from their German employers, they now applied under the American flag. The National Archives preserve photographs from August 27, 1918, showing the interior of the Bosch Magneto Company plant under alien property custodian control. The images show rows of women and men at workbenches inspecting parts, assembling magnetos, testing finished units on bench-mounted engines. The factory is clean, well-lit, orderly. The magnetos coming off the line are indistinguishable from those produced before the seizure, because they are the same magnetos, built by the same people on the same machines. The irony was profound. The United States government had seized a German factory because Germany was the enemy, but the factory's product was so essential to the American war effort that production could not stop for a single day. The workers who had been employed by a German company were now, without changing their workbenches or their tools or their skills, employed by the United States government building the same devices for American engines that they had previously built for American customers of a German company. War does not care about the nationality of the person winding a coil. It cares that the coil is wound correctly. After the armistice, the alien property custodian auctioned off the Bosch Magneto Company. A man named Martin Kern purchased the assets for $4.5 million. He quickly resold them to a newly incorporated entity called the American Bosch Magneto Corporation. The Fritz the Flyer logo, a goggled aviator that had been the original Bosch trademark, was retained by the new American company. So was the Bosch name, at least in the United States. Robert Bosch in Stuttgart watched his American operation disappear. In 1921, Bosch tried to re-enter the American market. He incorporated the Robert Bosch Magneto Company, Inc. to sell German-made products in the United States. Now there were two Bosch companies selling essentially the same products in the same market. The American Bosch Magneto Corporation sued. The case went to the New York Supreme Court. Justice Thomas C.T. Grain ruled against Robert Bosch. The Bosch name in the United States was declared the property of the American company. Robert Bosch, the man who had invented the product, built the company, and created the brand, was legally prohibited from using his own name to sell his own products in America. The post-war German-American treaty meant he could not even challenge the original wartime seizure. In response, Gottlob Honnold, Bosch's chief engineer, quickly designed a new trademark, an anchor inside a circle. It remains the Bosch logo to this day, a visual reminder of the moment the company lost its name in its largest foreign market. In 1930, the two Bosch companies reached an agreement and merged into the United American Bosch Corporation. Robert Bosch regained some presence in the American market. By 1920, the Springfield plant employed 3,000 workers and produced 50% of all electrical starter parts used by the American vehicle industry. The factory that had been seized as enemy property had become indispensable to American industry. And then, it happened again. On December 7, 1941, Japan attacked Pearl Harbor. 4 days later, Germany declared war on the United States. By the end of 1941, the United States Treasury had assumed formal operation of the Springfield plant. The Alien Property Custodian's Office, the same office created in 1917, reactivated by Franklin Roosevelt's Executive Order 9095 in March of 1942, took possession of all foreign-owned stock. For the second time in 24 years, the same factory, in the same city, making the same product, was confiscated from the same German company by the same American government agency. But this time, the stakes were astronomically higher. In 1941, the Springfield plant employed fewer than 1,000 workers. Its sales were $13 million. Then came the war contracts. The Federal Defense Plant Corporation provided $700,000 to build a new aircraft Magneto facility. An additional $4 million in leased machine tools followed in the spring of 1942. Employment surged from under 1,000 to over 7,300. Sales rose from $13 million in 1941 to $31 million in 1942 to a peak of $61.2 million in 1944. And now, consider the scope of what those 7,000 workers produced. By 1942, Bosch magnetos or fuel injectors appeared in virtually every United States-built airplane, every battleship, every aircraft carrier, every destroyer, and every submarine. The magnetos that fired the engines of the B-17 Flying Fortress, the P-51 Mustang, the P-47 Thunderbolt, the F-4U Corsair, the B-29 Superfortress, these were built in Springfield, Massachusetts by American workers in a factory that had been founded by a German, seized by the American government, sold at auction, partially returned to German ownership, and then seized again. Think about what that means in practical terms. The Pratt & Whitney 2800 Double Wasp, the engine that powered the Thunderbolt, the Corsair, the Hellcat, used a dual magneto with two 12-point distributors and 24 spark plugs. Every one of those engines needed magnetos. The United States produced nearly 300,000 military aircraft during the war, tens of thousands of tanks and armored vehicles, thousands of naval vessels. Every internal combustion engine in every one of those machines required magneto ignition or fuel injection, and a staggering percentage of it came from one factory in western Massachusetts. The workers who made this possible were not engineers from Stuttgart, they were machinists from Springfield. Women who had never seen the inside of a factory before 1941 learned to wind coils with the precision of Swiss watchmakers. Men who had been assembling automobile starters learned to build aircraft magnetos that could withstand the vibration of a 2,000-horsepower radial engine at 30,000 feet. The Alien Property Custodian set aside nearly $2 million from wartime profits as a reserve for post-war conversion, an acknowledgement that the factory's value lay not in its ownership, but in the skills of the people inside it. Robert Bosch himself did not live to see the end of this Second War. He died on March 12, 1942, at 80 years old, of complications from an ear infection, 3 months after Pearl Harbor, in the middle of a war he had opposed. He had come into conflict with the National Socialists in the 1930s. He was a liberal Democrat in the 19th century sense of the word, a man who believed in trade, in international cooperation, in the rational improvement of the human condition. His biographer, Theodor Heuss, who later became the first president of the Federal Republic of Germany, called him a civilization optimist. He died in Stuttgart while his factory in Springfield built magnetos for the bombers that would eventually destroy Stuttgart. The B-17s that flew over the Swabian Highlands in 1944 and 1945, dropping their payloads on the very city where Robert Bosch had opened his first workshop in 1886, those bombers flew because of magnetos built in a factory he had founded, by workers he had trained, using designs his engineers had created. The war consumed its own origins. There is a reason this story matters beyond the history of a single factory or a single product. The magneto is, at its core, a monument to the idea that precision is not national. The physics of electromagnetic induction, discovered by Michael Faraday, an Englishman, in 1831, does not care about the nationality of the engineer who applies it. A rotating permanent magnet generates a changing magnetic field. A changing magnetic field induces current in a wire. A step-up transformer multiplies the voltage, a spark plug fires, the fuel ignites, the engine runs. Robert Bosch did not invent the magneto, he improved it. Arnold Zeringer made it small enough for automobiles. Gottlob Honold made it powerful enough for high-speed engines. American workers in Springfield learned to manufacture it to German specifications, and then, when the German ownership disappeared overnight, they kept manufacturing it to the same specifications because the specifications were not German or American. They were physics. The Liberty Engine crisis of 1917 reveals a truth that would repeat itself across every chapter of 20th century military history. You cannot fight a modern war without precision manufacturing, and precision manufacturing does not respect borders. America needed magnetos. America could not build them. The only people who could build them were the American employees of a German company. So America seized the company and kept the employees. This is not a story of American ingenuity triumphing over German engineering. It is a story of German engineering being transferred, absorbed, and continued by American hands. The workers in Springfield did not reverse engineer the magneto from scratch in some desperate overnight effort. They already knew how to build it. They had been building it for years. What changed was not their skill. What changed was the flag flying over the factory. And what this story shares with every other chapter in this series, with the 100-octane fuel, the synthetic rubber, the quartz crystals, the antifreeze, the ball bearings, the radar magnetrons, the tank engines, the asbestos, is the same uncomfortable truth. The industrial foundations of American military power in the 20th century were never purely American. They were built on German chemistry, British physics, Swedish steel, Canadian minerals, and the labor of men and women who often had no idea they were building the infrastructure of a war that had not yet begun. After the war, the alien property custodian sold the Springfield plant in 1948 for $6 million to ARMA, a 2-year-old financial holding company headed by Charles Allen, the president of the Wall Street investment firm Allen & Company. The holding company's board included partners from several major Wall Street legal firms, as well as the presidents of the American Securities Corporation and the American Overseas Development Corporation. These were not manufacturers, they were financiers. In 1949, Allen merged the Bosch operation with ARMA Corporation, a Long Island defense electronics firm, to form American Bosch Arma. The Springfield factory continued producing fuel injection systems and precision components for decades. But the nature of ownership had changed fundamentally. Where the original Robert Bosch had been an engineer who ran a factory, the new owners were investors who owned a portfolio. The Springfield plant became one production facility among several, subject to the logic of capital allocation rather than the logic of engineering excellence. Employment fluctuated. Ownership changed hands. The connection to Robert Bosch's original vision grew increasingly tenuous. The plant that had once resembled a college campus Bright rooms, good ventilation, the values of a man who believed you should pay good wages before you made good money, was eventually shuttered. Low-wage, non-union plants in the South offered cheaper production. The skills that had been accumulated over 7 decades, the knowledge of coil winding, of magnet charging, of precision assembly, walked out the door with the workers who possessed them. The factory finally closed in 1986. The city of Springfield lost one of its largest and oldest industrial employers. The building that Robert Bosch had constructed in 1912, where American workers had built magnetos through 2 world wars and 5 changes of ownership, fell silent. Meanwhile, in Stuttgart, the real Bosch, Robert Bosch GmbH, grew into one of the largest engineering companies on Earth. Today, it is 94% owned by the Robert Bosch Stiftung, a charitable foundation. It employs over 400,000 people worldwide. It manufactures automotive components, industrial technology, consumer goods, and energy systems. Its logo is still the anchor in the circle that Gottlob Honnold designed in 1918, when the company lost its name in America. And every light aircraft flying today, every Cessna 172, every Piper Cherokee, every Beechcraft Bonanza still uses magneto ignition. 2 magnetos per engine, each firing its own set of spark plugs, each completely independent of the aircraft's electrical system. The technology is over 100 years old. It has never been bettered for reliability. Before every flight, a pilot performs a magneto check. Engine at cruise RPM, switch from both to left, note the drop in RPM, back to both, switch to right, note the drop, back to both. If the drop exceeds a specified limit, typically 175 RPM, or if the difference between the 2 magnetos exceeds 50 RPM, you do not fly. That check is a direct descendant of test procedures developed in Stuttgart before the First World War and refined in Springfield during both wars. The Bendix and Slick magnetos that dominate today's general aviation market are engineering descendants of the high-voltage ignition system Gottlob Honnold patented in 1902. The basic architecture, rotating magnet, primary coil, breaker points, condenser, secondary coil, distributor, has not changed in more than a century. It does not need to. It works. This is not nostalgia. This is engineering. A magneto is the most reliable ignition system ever devised. It has no battery to fail, no computer to crash, no wiring harness to corrode. As long as the engine turns, the magneto fires. This was true in 1897 when Arnold Zaringer fitted one to a 3-wheeler in Stuttgart. It was true in 1918 when American workers in Springfield built them for a government that had seized their employer. It was true in 1944 when 7,000 workers in the same factory built them for every Allied aircraft, every battleship, every submarine. And it is true today. Robert Bosch was a man who believed in international trade. He believed that commerce between nations reduced the likelihood of war. He opened factories in every major market, London, Paris, New York, Springfield, not because he wanted to dominate, but because he believed that local production, local employment, and local relationships created mutual dependence that made conflict irrational. He was wrong, of course. The mutual dependence he created did not prevent 2 world wars. It merely ensured that when the wars came, his own factories would be turned against him. His American workers built magnetos for American planes. His British subsidiaries were appropriated by the British government. His French operations were seized by the French. The very globalization he had pioneered, the same impulse that drives every multinational corporation today, became the mechanism of his dispossession. And yet, in some deeper sense, he was also right. The knowledge did not disappear. The skills did not vanish. The magnetos kept being built by the same hands to the same standards, regardless of which government's name was on the deed. Robert Bosch lost his company twice, but his engineering survived. His manufacturing processes survived. His insistence on precision and quality, inherited by workers who had never met him but had been trained in his tradition, survived both world wars, multiple owners, and the closure of the factory itself. Today, when a mechanic rebuilds a vintage American Bosch Magneto, one of the thousands still in service on antique tractors, old marine engines, and restored aircraft, they are working with a design that traces back to a small workshop in Stuttgart in 1887. The threads on the distributor cap studs are 5 mm by 0.8, standard metric, because Robert Bosch used metric fasteners. The coil winding specifications follow ratios established by Gottlob Honnold in 1902. The permanent magnets are charged using procedures developed in Germany and transmitted person to person across the Atlantic through 2 world wars to American hands that kept the knowledge alive. A German workshop, an American factory, 2 seizures, 2 wars, 100 years of continuous production. That is what a magneto teaches you about industrial power. It is not built in a day. It is not invented in a crisis. It is accumulated slowly in the hands and minds of trained workers over years and decades, and it persists through wars, through seizures, through changes of ownership and nationality, because the physics does not care whose name is on the building. The spark fires regardless.